Hey guys, I'm back with a numerical for the Kirchoff's voltage law. If you all haven't seen the previous video, I had explained what is Kirchoff's current law and what is Kirchoff's voltage law. If you all haven't seen, please go to the playlist in the current electricity module. You will find all the videos of the current electricity chapter, and there you will find what is Kirchoff's voltage law and what is Kirchoff's current law. Now let's start off with the numerical. Now this is a numerical which is given to us in the examination. We don't know from where the which direction of the current, where is from what is the value of the current, and from where this current is moving. So we make a assumption. Let's assume that the current is moving in the upward direction through the 6 ohm resistor. Okay, so we all know that the current moves from the positive terminal to the negative terminal. So this current, suppose this is current I1, so this current I1 will reach over here. Now this current I1, when it reaches to the junction B, it has to get bifurcated into two ways. Suppose it gets bifurcated into I2. So out of I1, I2 current flows in this direction. Therefore, what is the remaining current in this direction will be nothing but I1 minus I2. Okay. So this current I1 passes through this 2 ohm resistor. This is the positive and this is negative. Okay. Now this 2 ohm, now this current I2 moves to the C, and from C it goes to the 3 ohm resistor. Now 3 ohm resistor, this current will move from down to up, up to down. So positive terminal to the negative terminal. Okay. And now this current I2 will move in this direction, from it will come like this and move in this direction for 5 ohm resistor. So current moves from positive terminal to the negative terminal. Okay. Now again it has, so here from here I1 minus I2, this current will come from here, this branch, and from here I2 current will come. So they will meet at a junction E. So according to the Kirchoff's current law, at a junction these forces will get added, these currents will get added. So I1 minus I2 plus I2, I2 cancels off, and what we remain with is I1. So guys, you all must have noticed one thing, that we had started with I1 and again at the end what we are getting is nothing but I1. Okay. So now how to write the KVL equations for this new type of numericals? First of all, since there are two unknowns I1 and I2, we have to write two equations. So let's consider one loop A, B, C, A, B, E and F. So we consider this loop first. Okay. So what happens is that when we move from A to B, is there any potential drop, guys? No, it is just a conductor. So there is no potential drop. When we move from B to E, yeah, there is one potential difference created, which is at the 15 volts. So we don't consider the first sign, which is negative sign, we consider the second sign, which is positive. Therefore plus 15. Okay. Now when we move from E to F, is there a potential difference? Yes, there is a potential difference of 20 volts. When we move from E to F, we don't consider the first sign, we consider the negative second sign, which is nothing but equal to negative, therefore minus 20. And again when we move from F to A, what happens is that we don't, there is a potential drop across the 6 ohm resistor. We don't consider the first sign positive, we consider the negative sign. Therefore what is the formula for voltage is nothing but I into R. Therefore we take it as minus I1 into what is the value of R is 6, and sum of all this is nothing but equals to 0. So this is the first equation which we got. Okay. Now let's consider another loop, which is B, C, D, E, B. So let's consider the loop B, C, D, E and B. Now here when we move from B to C, is there a potential drop? Yes, there is a potential drop across the 2 ohms resistor. And what is the value of this potential drop? I2 into 2, because what is the formula for voltage? V is equals to I into R. The current through this 2 ohms is I2 and the resistor is 2 ohms, and we are moving from positive to negative, therefore we consider it as minus I2 into 2. Okay, now when we move from C to D, is there a potential drop? Yes, there is a potential drop created, and since we are moving from positive to negative, we consider it to be minus I2 into 3. And when we move from D to E, is there a potential drop created? Yes, there is a potential difference created, which is nothing but equals to minus 10. Don't consider the first sign, consider the second sign, which is nothing but minus 10. And when we move from this 5 ohm resistor, there is again a potential drop across this 5 ohm resistor, and we don't consider the first sign, we consider the second sign, which is nothing but equals to minus 5 into I2. Now when we move from E to B, what happens is that we don't consider the first sign, we consider the second sign of the battery. We are moving from E to B, we don't consider the first sign, we consider the second sign, therefore minus 15, and summation of all this is nothing but equals to 0. So you have got these two equations. These two equations are nothing but the Kirchoff's voltage equations. After solving these two equations, you will be getting the value of I1 and I2. Comment the values of I1 and I2 in the comment box. I will reply you all with the correct answer. Thanks a lot, guys.